This video introduces the pose adjustment strategy and specific parameter configurations in the depalletizing scenario. For this scenario, it's often necessary to specify the picking sequence of boxes. The pose adjustment tool supports various sorting methods, such as sorting by both Z and S shapes on plane. Here, we take sort by Z shape on plane as an illustrative example. Open Mech-Vision to enter hands-on examples. Click 3D Pose Adjustment. Select the corresponding project to create. Then, enter the project interface. Navigate to the step of Adjust Poses V2. Click Config Wizard to enter the tool interface. Configure orientation in pose adjustment. In depalletizing, the auto alignment function is often recommended. This function automatically aligns the object pose orientation with the Z-axis upwards. Additionally, select box palletizing and depalletizing as the application scenario. This option ensures maximum consistency of the X-axis orientation, avoiding unnecessary movements of the robot axes during the box picking process. Then, judge the box shape. If the box is rectangular, there are two picking methods as shown in the video. For a square box, there are 4 picking methods, making it easier to adjust the X-axis orientation. Thus, set a square size judgment threshold. This threshold is based on the difference between the box's length and width. Boxes with a difference within this threshold are considered square. The default threshold in the tool is 30 mm, but it can be modified based on the accuracy requirements for judging the square size on sites. Return to the graphical programming workspace. After selecting box palletizing and depalletizing, the Adjust Poses V2 step gains a new input port. This port will receive the data of box dimensions to judge whether the box is square. Connect the output port from the previously calculated box dimensions to the new input port of the Adjust Poses V2 step. For this, the tool can obtain the above-mentioned data. Go back to the pose adjustment interface. Click Get Data to receive the input pose and dimensions. Continue to set the target direction for the pose adjustment. In this scenario, the boxes are arranged alternately. To minimize the rotational motion of the robot when picking boxes under different arrangements, the manipulator is selected here to set the reference pose. Click the Set button to adjust the manipulator for the suitable pose. After adjustment, click Save. Moreover, the orientation is configured as positive X direction. Click Next. Configure the sorting type as Sort by Z shape on plane. With the incoming object position fixed in this scenario, set the reference pose parameter as Drag with Pose Manipulator. This parameter determines the starting point of picking. Now, we want the picking sequence as shown in the video, taking the box in the top right corner as the first picking point. After that, click Set to adjust the manipulator pose to the top right corner. Once adjusted, click Save. Also, to ensure the optimal picking sequence, set row direction to point towards the positive X-axis of reference pose, and the column direction towards the positive Y-axis. Besides, configure row interval to match the interval between the rows of objects in the real scenario. Click Next. Finally, we need to output the box dimension data corresponding to the sorted poses, so set the number of new ports to 1. Navigate to the graphical programming workspace. For this, the Adjust Poses V2 step will add an input and an output port for receiving and outputting the box dimension data. Connect the output port from the previously calculated box dimensions to the new input port of Adjust Poses V2. Then, connect the new output port of Adjust Pose V2 to the input port from the following step. Return to the Pose Adjustment tool. Click Get Data. In the depalletizing scenario, the above are all configurations for the sorting by Z shape on plane. The poses adjusted by this tool can be subsequently sent to the robot to accomplish the picking task. For the pose adjustment tool applications in other scenarios, please refer to the hands-on examples in Mech-Vision and corresponding documentation.